I'm Manoj from Kannur, Kerala. This time I would like to say something about what is secondary reference electrode. In the last class, we discussed about primary reference electrode, SHE. Today we are going to talk about what is Calomel electrode, secondary reference electrode. See, lot of limitations are there in SHE when you deal with SHE. It is very difficult to get pure hydrogen. It is difficult to maintain pressure of hydrogen gas at 1 atmospheric all time. It is difficult to set up and transport standard hydrogen electrode. So as an alternative to the limitation, what we face, what we faced during the operation of SHE, secondary reference electrodes are come in use. They are Calomel electrode, glass electrode, quinhydron electrode, etc. Let's get started with Calomel electrode. Please take a look on the screen. This is particular Calomel electrode. It consists of a glass tube having side tube, where side tube functions as salt bridge. The bottom of the tube is filled with mercury, above which a paste mercurous chloride, it is known as Calomel, and the remaining portion, including the side tube, is filled with potassium chloride solution. And a silver chloride coated silver wire kept at the center in order to get electrical contact with the other half cell with which it coupled. See, a particular cell, when you measure the E cell value, E cell is the difference in potential of two half cells. You are not able to measure the exact potential of an individual electrode. So here, based on the difference in concentration of potassium chloride we choose, it could be sometimes decinormal or normal or saturated solution. They can have three different Calomel electrode possible. We are having three different Calomel electrode based on the difference in concentration of potassium chloride. So for decinormal, if it is decinormal Calomel electrode, it is known as DNCE, decinormal Calomel electrode. And for one normal, it is normal Calomel electrode, NCE, and saturated solution, SCE. So with varying concentration of potassium chloride, there are three different Calomel electrode available, possible, and they can have three different electrode potential values. They are respectively, in the case of decinormal Calomel electrode, it is maximum 0.3335 volt. And in the case of normal Calomel electrode, it is 0.284 volt. Saturated, highly concentrated solution. In the case of highly concentrated solution, it is only 0.242 volt. Okay, so they have a definite positive value of electrode potential. It can be measured by using a standard hydrogen electrode. Already it has been measured. So it is known as a standard Calomel electrode. The possible reaction happens in this cell. Please have a look. If there is a particular oxidation happens, mercury oxidizes to corresponding ion, and the mercurous ion take chloride ion from potassium chloride solution to form mercurous chloride, and just reverse reaction happens if it undergo a particular reduction reaction. See, mercurous chloride first decomposes, then the formed mercury take electron and reduces to mercury. Just reverse reaction. Most probably it undergo reduction reaction. You know, the position of mercury occupy at the lowest position in electrochemical series. It's not occupy at the middle or top. very low activity. So most probably it undergo reduction reaction. Very little chance to undergo oxidation. Anyway, this is the reaction possible in Calomel electrode. Either oxidation or reduction happened. So that's all about a particular Calomel electrode. So let me conclude. Calomel electrode actually consists of a glass tube having side tube, where side tube functions as salt bridge. Okay, and the bottom of the tube is filled with mercury, above which a paste of mercurous chloride, remaining portion including the side tube filled with potassium chloride. Owing to the difference in concentration of potassium chloride we choose, they can have three different Calomel electrode. They are desinormal, normal, and saturated Calomel electrode. They have definite electrode potential value, respectively 0.335 volt, 0.284 volt, 0.242 volt, respectively. Okay. And you are also able to predict whether it undergo oxidation or reduction reaction. See, if it undergo oxidation reaction, what happens? The consumption of mercury takes place, the formation of mercurous chloride. So from the size of mercurous chloride and mercury, we are able to predict whether it undergo oxidation or reduction. If it undergo reduction, what happens? The size of mercury goes on increase, the size of mercurous chloride decreases. Okay, so that's all about secondary reference electrode Calomel. Thank you.